Today we're going to talk about power. This time we are going to find the power transfer from the system to the user U in 24 hours, which is a reasonable amount of time. So let's crack on and draw our circuit just like we always do. So we're going to have a voltage supply and a resistance and then another resistance and then a point which I'm gonna call A, and then another resistance, and then a diode polarized in this direction, so it's not gonna let current flow through in this opposite direction, but it's only gonna make the current it's just gonna allow the current flow in this direction. And at the bottom we're gonna have everything connected like that. So from here, there's gonna be a resistance going down to here, and another resistance all the way down here. I'm gonna have another point here, which we're gonna call B. And I'm gonna just call my voltage source plus minus V. These resistance are 1, these one are 2, these one are 3, these one are 4, and these one are 5. Now, the problem is saying that for the circuit on the left, we know that V is equal to 12 volts, our I is equal to I ohm, so 1, 2, 3, 4, and 5 ohms each. Find the energy W transferred from the system to the user U in 24 hours, and the power P transferred from the system to the user. Okay, so first thing first, well, let me just write everything here. So we know that this one is 12 volt, this one is 1 ohm, 2 ohms, 3 ohms, 4 ohms, and 5 ohms. So we can actually draw the, well, we can actually find the equivalent circuit of Thevenin to the point AB. In order to do so, I'm going to rewrite everything with just the point AB. So I'm going to ignore this at this given moment in time. So if I'm going to consider AB, I will just have this part of the circuit. So my voltage supply, my resistance, a node, this other resistance, and then all the way down here to A, and nothing here. And then at the bottom, I'm gonna go down all the way down to B, and then I'm still gonna have those resistances here and this resistance here. So I'm gonna define I flowing in this direction as I total, and here I'm gonna have my V, which is 12 volt, my R1, which is 1 ohm, my R2, which is 2 ohms, my R3, which is 3 ohms, my R4, which is 4 ohms, and that's it. Now, in order to find the equivalent circuit of Thevenin to the point AB, I'm going to find, first of all, R Thevenin. So R Thevenin in this particular circuit is going to be R1 in parallel with R2 plus, and then plus RT, all in parallel with R4. So R1 in parallel with R2 plus R3, all in parallel with R4. So R1 in parallel with R2 plus R3, all in parallel with R4. So if we plug numbers back into this, we're gonna get 1 in parallel with 2 plus 3, all in parallel with 4. So this is actually going to be, well, RTH will be 1 times 2 over 1 plus 2, so the product over the sum, all plus 3, and then all in parallel with 4. So RTH, R Thevenin, will be 2 times 1 is 2, 2 plus 1 is 3, all this plus 3. Didn't really need the parentheses, that's why I put it here. So RTH, I will basically have, well, 3, 2 is 9, all in parallel with 4. So RTH is 9 plus 2, which is 11, over 3, all in parallel with 4. So RTH, I don't like fractions, 11 over, 11 over 3 is 3.66. You can write this at 3.66 in parallel with 4. So RTH is just 3.66 times 4 over 3.66 plus 4. So actually I have RTH equal to, well, 3.66 times 4. If I save this into n's, it will be n's times 4, 14.66. Everything over 3.66 plus 4 is just 7.66. But I'm lazy, so RTH is just 14.66 over 7.66, which is 1.91. Yeah, just gonna go for 1.91 now. So 1.91 ohm. Now VTH will be equal in this case to VR4, so the V across here, okay, where I'm measuring it. So will be VR4. But VR4, because of Ohm's first law, we know that V is I times R. So in this case is I4 times R4. Makes sense, right? Now, we gotta find I4 first, because we don't actually, well, we do know R4, which is 4 ohm, but we don't know what I4 is. So we gotta find I4. Now, to find I4, we actually have to find R total and I total. So let's do this. We can say, okay, R total is R3 plus R4, all in parallel with R2 plus R1. So R total for this circuit is 3 plus 4 in parallel with 2 plus 1. So our total will be 4 plus 3, which is just 7 in parallel with 2, all plus 1. So our total is the product over the sum. So 7 times 2 over 7 plus 2 plus 1. So our total is 7 times 2 is 14. 7 plus 2 is 7, 8, 9. Oh, plus 1, of course. So our total is, well, is 9, 14 plus 9. So our total is 19, 20, 21, 22, 23. So 23 over 9, which I can also write as 23 over 9 is about 2.55. Oh, now that I have the R total, I can use it to find the I total. And once I found the I total, I can use it to find I4, which is a subset of I total. So I total will be V over R total, which we have just found. So I total is, was it 12? Yeah, 12 volts over R total, which is 2.55. So I total, 12 over 2.55. Let me fire up my calculator again. Oh, I already have the ends. So 12 over ends, 4.69. Well, I'm gonna go for, well, there is a 9 there, so I'm gonna go for 4.70 amps. 4.70 amps, which is my I total. Now I have everything I need to find I4. And with I4, I will have everything I need to find VTH. So I4 is therefore going to be a subset of I total. So it will be I total times, well, R2 over R2 plus R3 plus R4. So I4 is therefore going to be I total, which is 4.70 times, R2, which is 2, R over R2, which is 2, plus R3, which is, 3, plus R4, which is 4. So I4 is, well, 4.70 times 2 is just 9.4 over 2 plus 3 plus 4. So I4 is 9.4 over 3, 4, 5. We have 4, 4, 5, 6, 7, 8, 9. So over 9. Now, we can actually simplify it. Well, not like simplify. We can actually write it as not as a fraction. So 9.4 over 9 is just going to be 1.04 amps. Now, the reason why we have found all this is that now I can plug I4 back into here and find VTH, so V Thevenin. So we said that VTH is I4 times R4. Therefore, VTH is 1.04, which we had just found, times R4, which was 4, was given to us by the problem. So VTH is 1.04 times 4, which is 4.16 volt. Now, the diode that we have found the RTH and RTH, which is this one, and VTH. So R Thevenin and V Thevenin. Now, the diode that we have here can actually be substituted with a short circuit because it's polarized directly, so down here, and the current is actually flowing in this direction, so it's going to let the current go through. And it's not a real diode, it's just an ideal diode, so it doesn't have any resistance at all, any internal resistance at all, because it's an ideal diode. So we can actually substitute it with a short circuit. So now we can finally draw the Thevenin equivalent circuit, which I'm gonna do, I'm gonna do it here. So the Thevenin equivalent circuit for this circuit is going to be, we'll have the, well, remember the Thevenin equivalent circuit is a voltage supply in series with the resistance. But since we have done all here across the point A and B, we're also going to have to add this part. But good news, as I said, we can just swap this diode, with this ideal diode, with a short circuit, so just with the cable, so with a line, because it's not going to affect our circuit. It's polarized in the right direction, so it's going to allow the current flow through it, and it's going to be fine, perfectly fine. So we have a voltage source in series with a resistor, just like as by definition of the Thevenin circuit, equivalent circuit. So those two are going to be my point A and B. And down here, I'm going to have my resistor R5. Like so. And I'm not going to have the diode anymore. because as I said, it's going to let the current through. It doesn't have any internal resistance, so I can just ignore it and go on. So what's left? Well, the problem was actually asking us to find the the power, of course, and the energy. So the power, we have done this several times. If you remember Ohm's third law, the power is I squared times R. So in this case, we're going to have I squared times, R5 actually. This is RTH, and this is VTH. So in this case, it's going to be I squared times R5. So power will be R5 times, what's I squared? Well, in order to find the I in this circuit, we would have to use, I, if you remember Ohm's first law, Ohm's will be V over R. And in this circuit, we have this resistance and this resistance. So I, in this case, will be VTH over RTH plus R5 squared. So P is actually, R5 was 5 ohms. Those were, these was 5 ohms. These was, VTH was 4.16 volt. And RTH was 1.91 ohm. 1.91 ohm. So essentially we have the voltage, so 4.16 over RTH 1.91 plus R5, which is 5 ohm. So P is 5 times, let's see, 4.16 over 5.91. So P will be, I'm just not lazy, I'm just gonna put everything into, I'm just gonna put everything into my calculator. So, I was almost forgetting the square. So it will be 5 times 4.16 times 4.16 is 17.30. So we have 17.30 over 5.91 times 5.91 is 93, because we have a 92.8, so 93. So power will actually be 17 times 30 times 17.30 times 5, 86.5 over 34.93. So P is going to be 86.5 over 34.93, 2.47 ish. 2.47. Is that right? Is it 2.47? Is it 2.47 watts? Let me just do it quickly again. So will be, oh no, it's 1.91 plus 5 is 6.91. So 6.91 times 6.91 is 47.74, so this is 47.74. So 86.5 over 47, made a mess, 47.74. So 86.5 over 47.74 is 1.81, about 1.81. So yep, this is not 2, this is 1.81 watts. So we are halfway, well, no, more than half, we're almost over, because we have found the power. And the other thing that the problem was asking us to find is the energy transfer. So the energy, which we're gonna call W, the energy is actually P times T. So basically the power transfer in the constant of time, which is 24 hours. So I'm gonna use WH, watt per hour in this case. So I can just lazily multiply 1.81 time and do 1.81 times 24. So 1.81 times 24, which is the hour, the amount of time we have been using this appliance. So the energy is 1.81 times 24 is about 43.44 watts per hour. So that's it. By using this appliance for 24 hours, we have seen that we've been using, well, we have 43.44 watts per hour. So yeah, that's pretty much it for this problem.